Greetings. Welcome to SUSECON session TUT1309, major version upgrades in the public cloud using the SUSE public cloud distribution migration system and SUSE Manager. My name is Jeff Lindholm. I'm a technical sales director with SUSE out of Detroit, Michigan. I lead a team of pre-sales professionals that are focused on working with customers to solve problems. Today's session is going to be reviewing best practices for how to upgrade long-running instances in the public cloud from SLES12 SP4 or 5 to SLES15 SP3. About a year ago, we were challenged by one of our large customers in the Midwest to help them with a process to upgrade long-running instances in Azure, and they have a variety of deployments looking at long-running reserve instances in infrastructure virtual machines, as well as on a large instance, which is a physical tier deployment in the Azure environment. They were also a SUSE Manager customer and wanted to reuse the investments that they had previously made. Through the collaboration of our engineering and product management teams and a little bit of help from SUSE Consulting, we were able to put together a process that I wanted to document and share with the world in this session. So we're going to spend some time over the next 30 minutes talking through the process and then showing you a live execution of this. So 20 minutes will be in the presentation, about 10 minutes related to demo, and then some follow-up towards the end. To get started, we're going to talk through the upgrade process and point you at the documentation that is available to support you as part of planning your upgrade. We'll do a very brief overview of the public cloud distribution migration system and why SUSE Manager makes sense in this context. And then we'll look at the hands-on components. So if we think about the reasons and the need to upgrade from SLES12 SP5 to SLES15 SP3, it comes down to support lifecycle, alignment from a workload perspective with partners like SAP. If you look at our ability to do major version in-place upgrades, we've had this capability for better than 10 years. It's a proven process and ultimately one that I believe adds quite a bit of value looking at long-running instances that you want to maintain and keep up to date. Major components involved in this operation include the public cloud distribution migration system, which is a component of SUSE Linux Enterprise Server that's maintained by the public cloud engineering team. We have SUSE Manager, which is our full lifecycle management systems configuration management tool that does content lifecycle management for staging of patch updates, security, auditing and reporting, looking at CVEs and vulnerability analysis, as well as state management and remote execution, which can get you quite a bit of orchestration and automation, looking at controls within your environment. We also have provided the documentation on how to upgrade to SLES15 SP3. The QR code at the right has links to all three of these documentation references at the bottom. I'm also going to request that a PDF be posted along with the session slides that goes through a step-by-step of the process along with example configuration files to support the salt states that are needed for the upgrade. That way you can cut and paste those and experiment within your lab. So before we get started, a couple of best practices that I want to speak to. As mentioned earlier, we've been supporting major version upgrades for quite some time, better than 10 years. We started this with SLES 10, moving to 11, 11 to 12, 12 to 15. We've got a lot of flexibility. There are different ways of doing this. We have the unattended upgrade process, which is an extension of the SLES installer. That could be automated with SUSE Manager and Cobbler. It's not necessarily relevant to the public cloud environment because of access issues and console access controls. Ultimately, we've learned quite a bit during this process, and one of the critical success factors I would point out is that you really need to test this upgrade process in pre-production to validate that your results are expected, that your workload that's running on the server, which is the most important part of the deployment, is operating as expected, and that you've met ISV requirements looking at version controls of the workload that you're deploying. This pre-prod testing is highly recommended. A qualified partner or SUSE Consulting could very easily help with this. I would also advocate that you need to make sure that you've got solid backup, test, and restore capabilities. You need to verify your processes and document as you're planning your upgrade step-by-step procedures that your administrators can follow. That way we have a reproducible process that SUSE can help support you with. When we look at the distribution migration system, it was specifically built to upgrade virtual instances in the public cloud. DMS offers a cloud-friendly major version upgrade capability, and SUSE Manager adds some automation and content lifecycle management to drive additional economy and efficiency as part of this process. When we look at upgrades in the public cloud, there are some assumptions that I think resonate across all the hyperscalers and many of the tier 2 providers. When we look at the operation scenarios, access to server consoles, the bootloader, the ability to bootstrap an operating system installer that would be used with the unattended upgrade process is pretty limited. Ultimately, by coming up with a fully automated solution that runs independent of SUSE Manager using the variety of update repositories and services that the cloud providers are providing as part of the subscription service, we've streamlined the process and made the public cloud distribution migration system tool available to support upgrades. DMS is available and relevant to all SUSE certified public cloud providers. DMS has also not only been automated, but it has been configured with fault tolerance in mind, meaning that if there's a failed upgrade, the system will revert and reboot to the previous state. And ultimately, there are a few things about DMS that stand out that make it effective in delivering this capability. When we look at how DMS operates under the covers, it utilizes Zipper in a chroot environment to facilitate the major version upgrades. This is a bit different than a standard SLES12 to 15 upgrade that you might do with the installation media. SUSE, prior to DMS, has required that the installer be used to facilitate the upgrade by using DMS, which creates a live boot image, and mounting the root file system in a chroot system mount point. We can use Zipper migration or Zipper dupe to accommodate the upgrade process. Zipper understands how to manage the dependency chain. It understands the overlay of the repositories that are required based upon the channels that have been assigned. Ultimately, the DMS process can be triggered via kexec, meaning that a reboot is ultimately not even required to start this process. Kexec is a stub kernel environment that can bootstrap the live image on a currently running system. This has the benefit of having currently configured networking and storage available within the instance. This is actually exceedingly important in the public cloud, especially looking at physical hardware tiers. Networking, load balancers, and infrastructure are complicated, and having a full networking stack gives us quite a bit more flexibility. The system can be accessed during the upgrade process. We'll talk about how we accomplish that via public keys as part of the steps in the process in the next few slides. And the system will use a set of Python scripts to ultimately execute and clean up the upgrade process at the end of the scenario. When we look at why SUSE Manager makes sense here, first and foremost, we have a number of customers that take advantage of SUSE Manager in the public cloud. If you're consuming SLES for SAP applications in the public cloud marketplace, software entitlements for SUSE Manager are included with your maintenance spend for the marketplace instances. So no need to purchase lifecycle management if you're consuming from the marketplace, making it easy and potentially a default option for managing your environment. We also needed to avoid a scenario where we were deregistering instances and re-registering instances for currently deployed infrastructure. We want to manage risk and limit the number of changes and basically have a fully prototyped and well-tested process to support this upgrade. The other pieces that SUSE Manager brings to the table include enhanced software release management, looking at the content lifecycle management capabilities that can be used for promote to production staging. So the same channels that you're using to maintain your currently deployed infrastructure can be used to facilitate the upgrade, which has the benefit of consistency. You can also count on the remote execution capabilities of the SALT open source project, as well as SALT states to implement pre and post upgrade steps. This can help with staging and preparation for the upgrade if there were changes that you needed to make to facilitate workload readiness or other tidying or housekeeping that needed to be done. SUSE Manager can very easily get that done as part of the DMS migration configuration state. SUSE Manager also centrally logs execution of the upgrades and can help audit for completion. And you do have the ability to add third-party software channels to help with deployment at scale. Today's demonstration is going to be looking at a single instance migration. You absolutely can add additional orchestration, and we can talk about opportunities for that in a few slides to make this work with more than one instance. That said, most of our customers are taking these in batches depending upon the criticality of the instance and how many instances they need to upgrade and how uniform their servers are. So if we look at the steps on the path to results, there are a few assumptions. One assumption that we need to change the behavior in SUSE Manager of is that there is an assumption that registered devices have access to software channels. In order for us to use the software channels out of band, we need to detokenize the access to those channels, and there is a configuration change in the rhn.conf file that needs to be made to facilitate that level of access. You need to make sure that the required software channels are mirrored and available on the SUSE Manager server. As part of the upgrade process, we need to tell SUSE Manager to get out of the way so that we can assign the SLES12 software channels to facilitate the upgrade. To do this, we'll create an empty-based software channel called DMS migration. And we will also create a set of activation keys and configuration channels to facilitate the preparation for the upgrade and prepare us for actually running the process either via kexec with run migration or via reboot. I'm also going to point out opportunities to use system reactivation keys during the upgrade process to help with retaining target system configuration and log history. Should be pretty straightforward. If we look at the public cloud instance assumptions, number one assumption is that you have a SLES12 SP4 or 5 or SLES for SAP12 SP4 or 5 instance under the control of SUSE Manager that we can apply the DMS migration states and software channels to facilitate the upgrade. Again, I'm going to suggest full system backups with verified ability to restore. You need to be able to iterate this process and fail back in the event that you have a problem. Public cloud instance snapshots are definitely sufficient. The pre-production upgrade testing and workload validation is absolutely required. Checking with things like the SAP product availability matrix and other ISV certification requirements is highly recommended, at least temporarily. We would recommend copying a public key to the root user on the instance so that the migration user can access the system during the upgrade. That way you can evaluate the logs and the stepping and staging of the process and troubleshoot in the event that there was a problem. And beyond that, there's the table stakes of working DNS resolution and potentially a hard-coded fully qualified domain name entry in Etsy host, just to make sure that the client can resolve the SUSE Manager server properly. 2 software packages will have to be installed to facilitate the upgrade. These are SLES15 migration and SUSE migration SLE15 activation RPM. These come from the SLES12 public cloud tools environment. So to kind of walk you through the details along with the instructions that will be provided, I've created a few slides that just kind of give you the highlights. How we go about detokenizing the SUSE Manager software channels is documented here. It's a modification to rhn.conf. we set check download tokens to false. And what this will allow is a specially crafted URL with the channel label at the end to be used as part of the identifier for the software repository so that the system can gain access to the lifecycle managed channel. Step number 2 is going to be creating the controls for the distribution migration system. There's a YAML file that needs to be placed in the etc directory. There are 2 parameters that we will populate, one that controls whether DMS is using zipper migration or zipper distribution upgrade. The second one is whether or not you want debug enabled. If we have debug set to true, this gives you an opportunity to access the instance prior to the system rebooting at the completion of the upgrade, or if the upgrade has had a challenge, and it'll give you the opportunity to go look at distro migration log to validate where that challenge is coming from so that you can resolve it. Ultimately, the configuration file parameters for DMS are documented out at documentation.suse.com. Highly recommend you taking a look. Again, I will emphasize DMS has the ability to run outside of SUSE Manager. You can set target versions in the config file for zipper migration. In this case, though, we're going to be using zipper distribution migration or zipper dupe, which is why zipper migration is set to false. Step number 3 and 4 are going to be completed in the SUSE Manager web UI. We are going to create a base software channel with no contents. And we will also create a set of activation keys and configuration channels to manage the salt states for deploying the software repositories and the configuration changes needed to facilitate the upgrade. If we look at the salt state that we're preparing, it's pretty simple. We're going to be calling 2 modules, one of which will distribute the etc SLE migration service YAML from the salt master, which is this file.managed salt state. We also have the package repo.managed salt state that will create repositories on the instance as part of the salt state outside of SUSE Manager's control, and these will be referenced by zipper dupe as part of the upgrade process. You do need to have an entry for each channel required to facilitate the upgrade. And again, an example in it.sls will be found in the instruction PDF. If we look at the activation key, this would be used by the bootstrap script to start the staging process. Once the staging has been confirmed to be complete, we have the ability to execute the migration. The only change that I would recommend to the bootstrap script is setting disable local repos to 0. Because we have a salt state that is manually creating repositories for the SLES12 upgrade, we do not want SUSE Manager to disable those repos as part of rebootstrapping of the DMS migration channel. DMS and SUSE Manager are pretty smart. SUSE Manager in particular will typically prevent you from assigning SLES15 channels to a SLES12 server. In this case, this is where the euphemism of telling SUSE Manager to get out of the way with an empty channel comes into play. We're also telling SUSE Manager not to disable the local repos so that the upgrade process can complete. So it's time to upgrade. Looking at the upgrade process, we're going to bootstrap a specially created image with SLES12 SP4 for SAP. As part of that bootstrap, we will include the public cloud tools channel. We'll inspect the assigned repositories and the OS version prior to the upgrade. We will install the SLES15 migration packages, as well as the activation package that modifies Grub. And then we will create a reactivation key that will allow us to keep this bootstrap process associated with this endpoint device. It's important to note that you can also generate reactivation keys via the SUSE Manager API if you were scripting or further automating this process. When we look at how we bootstrap the environment to start the migration process, we need to export the reactivation key in a root shell, and then we're going to execute the DMS migration bootstrap script with bash, and that will then change the base channel assignment and implement the salt states to prepare the server for upgrade. A list of the required repos after the salt state has been applied can be viewed either at the client or from the perspective of the managed endpoint. And optionally, again, you're going to want to use a tool like SSH Copy ID to copy an authorized key to the root user account that will be cloned into the migration user within the live boot system so that we can monitor the upgrade. After these steps have been completed, you can then execute the upgrade using run migration or reboot the system. And then monitoring is accomplished as documented below. Let's take a closer look at how we can do this hands-on. So if we look at our web browser, I can log in as an admin user to the SUSE Manager console. This is SUSE Manager 4.2. It's currently patched environment. I currently do not have any systems configured, but I do have software channels configured. And if you look, I have the DMS migration channel and all of the media repos that are here, right? If we look at the SUSE Manager server, I can very quickly show you that the rhn.conf parameter has been changed. I have already restarted the spacewalk service to save some time. And I am also going to change the size of this window so you can see the bottom of it. Other thing we're going to look at here in the SUSE Manager server is under serve salt etc. The salt master is going to contain the SLE migration service YAML. And this is where we're going to declare that zipper distribution upgrade and debug are configured appropriately. Debug will be disabled and zipper migration will be set to false. So looking at the software channels in the web UI side, continuing with the SUSE Manager configuration, you'll see that there are no packages, patches, or systems assigned. I also have a configuration channel that was created, DMS migration, and if we view the init.sls, you'll see that the modules as referenced in the presentation are here. So the file that I just showed you in the terminal will be distributed by the file managed state from the salt master to etc SLE migration service. And I'm also creating a number of out-of-band package repos that have been labeled DMS-channel name, pointing to the specially crafted URL with the SUSE Manager channel labels that you would like to use to facilitate the upgrade process. This is how we can use content lifecycle managed channels to drive the upgrade. So the SUSE Manager server infrastructure is prepared. Let's go take a look at the client side, and then we'll eyeball how to bootstrap this server and get it activated. Currently, I'm on a server that I've named sap001.calmelian.net. This server is running SLES12 SP4, and it's not currently bootstrapped within the environment, right? If we look at the bootstrap keys, I've got one here for SLES12 SP4 full that has mandatory channel assignments, and I've added the public cloud tools channel. We also need to just very quickly look at the DMS migration key, which again has no child channels assigned, but it does have the DMS migration salt configuration channel assigned so that when we bootstrap this instance for a second time to start the staging process, the salt state will be applied as expected, right? So if we look at bootstrapping this instance, it currently has no repositories assigned. If we execute the bootstrap script with bash, the system will use the SLES12 SP4 SAP full activation key to onboard the instance with SUSE Manager. If we go back to the web UI and look at the salt tab, you'll see that there is a new minion accepted here for SAP001. And if I go back to systems, this system is in the process of applying its high state. And you'll see that the base channel has been assigned along with the public cloud tools channels that are needed to install the SLES12 migration packages. We're going to give this another 5 to 10 seconds to complete its high state execution. You'll see that its checkbox status is green now, and the events from the onboarding are now in history and they've completed successfully. If we come back over here and we type zipper refresh, you'll see that I now have repositories provided by SUSE Manager on this instance. And I'm going to install the SLES12 migration packages from the SUSE Manager server, right? So this will happen rather quickly. Next thing we're going to do here is log out of this system, and we're going to copy the SSH key that's needed for access during the migration to the root user from my local account. And we're just going to call this sap001.calmeleon.net. We'll give it a password, and we'll confirm that we can SSH to the box with no key needed at this point. The next step in the process is to generate a reactivation key. If we generate a new key and copy this, we have the ability to come back over here to the terminal and export this as a variable. This variable will be used by the Bootstrap script to keep the device association as we change channels. So I'm just going to paste this here. And unfortunately, I ended up with a space as part of the paste. Happens sometimes. That's done. The next step on the path is going to be rebootstrapping this instance with the DMS migration channels. And you'll see here specifically that we've used the DMS migration key along with the reactivation key. The reactivation key is this key right here. And if we go back to the systems view and we look at the details on this device and go to events, you'll see that the device has rebootstrapped. And if we go back and we look at the details, its base channel is now DMS migration with no child channels. And if I do a zipper ref here, all of the repositories are up to date for the SLES12 environment, meaning if I type zipper repos, you can see that these have been assigned. Make this a little bit smaller and spread it out a little bit so that you can see. So we're good to go here. I'm going to open up a new terminal, and I'm going to run a ping on sap001.calmeleon.net. And we are going to come back over here now that we have the staging complete. We have the Etsy SLE migration service YAML on this device. And we have the zipper dupe channels assigned along with the SLES12 migration packages in place. I have the ability to run migration, which will start the migration process. In the background, the system is using kexec to bootstrap a live OS image that has been specially packaged and installed as part of the SLES12 migration package. This takes about 15 seconds to initialize, and in a moment the system will come back and start pinging. The upgrade process has started here now at this point, and if we SSH migration at sap001.calmeleon.net, I'm now in as the migration user. Change to the root user, and we can go to /system root, which is the root directory structure for the root file system of the real operating system image, and we go under var log. And if you do a tail -f distro migration.log, you'll see the process working in the background. So this is going through and installing all the RPMs after the file copy has taken place. This image I'm using today is a specially crafted image that I've put together using one of our juice images that reduced the package count significantly so that the upgrade would complete much more quickly. So instead of about 2,200 packages in a default install, we've got about 477 here. And as we're waiting for this to finish, I've got a few considerations I want to go back and finish up. So, a couple of things we learned during the process working with our customer and their use case was they had a variety of instances they needed to upgrade. And as I mentioned earlier, the DMS system was built initially to support migration of cloud virtual machines, whether they're on AWS, Azure, Google, or a tier 2 provider. Didn't matter. It can frankly work with virtual machines running in KVM. It can run with physical servers. The infrastructure is pretty neutral. But with respect to supporting physical servers in the public cloud, one of the things that we identified at the end of the process is that we needed to build what the developers referred to as a fat initRD that included all the drivers needed, for example, related to an Azure HLI on a large instance, which is a physical hardware tier, so that all the multipath drivers and device mapper drivers and other required infrastructure was included as part of the last mile of the upgrade process. There is a parameter that's been added that you can put into the SLE migration YAML configuration file that will facilitate that happening at the end of the upgrade process. Another thing that I would offer for consideration is you might want to consider disabling Chef or other configuration management tooling. If you're using other automation tools that are coexisting with SUSE Manager, you need to make sure that they're not stepping on top of each other during the upgrade process. It's perfectly fine to re-enable those tools after the upgrade is complete. As mentioned previously, additional automation and orchestration can be added to execute this process at scale. I know that reactivation keys, for example, can be generated via the SUSE Manager API. And ultimately, one other thing that was identified in particular with this customer is they had a SSHD configuration parameter that had been deprecated, moving from SLES12 to SLES15, looking at the version upgrade for SSH. And as typical, this was caught in their pre-execution testing so that they were able to validate their SSH configuration and make changes prior to the upgrade so that users would not have issues logging into the environment. Lastly, prior to going back and looking at the end result of the upgrade, I'm going to offer for consideration that support and services are available if you need help. Firstly, all level 1, 2, and 3 technical support for SUSE Manager is provided by SUSE. Even if there is a software entitlement tied to SLES for SAP applications in the public cloud marketplace, the SUSE Manager tickets are routed to SUSE for break fix. If you have questions about SUSE Manager support, subscriptions, or you need technical assistance, contact your SUSE representative. Call your account executive, call a qualified partner, call your pre-sales engineer. Your service offerings and support engagement policies may vary on a per cloud provider basis. And if you need architecture and process help beyond break fix, I'm going to encourage you to engage with our partner channel. Professional services can very effectively come in and help you streamline this process to reduce the amount of time required, whether you're working with a SUSE 1 Gold or Platinum partner, or you're working with SUSE Consulting. We've got a lot of flexibility to either do a review of the process or help orchestrate the execution of the process. So, speaking about the cleanup side of the demo, the last thing we're going to show you here is reactivating this instance with SUSE Manager now that it's SLES15 SP3. You'll see in the web UI in a moment that it still has the DMS migration channel assigned to it, so we're going to need to run one more bootstrap. There's a little bit of cleanup required, looking at orphan packages in the DMS repositories that need to be cleaned up, at which point you can resume normal operations. The tip I have here in red at the bottom is just a highlight that the RPMs on your server should be coming from software channels that are assigned or managed. The definition of an orphan package or a non-compliant package from a SUSE Manager perspective is an RPM that's not owned by any software channel. And occasionally, if you've manually installed RPMs or if there were some lingering packages that were not upgraded, that were removed from SLES15, they may need to be individually evaluated and removed, or you can remove all of them using the zipper command in the fourth bullet point. Let's go take a last look at the finalization of this process. If we go back to the SUSE Manager system state, you'll see that the system is now reporting as SLES15 SP3. I also have the system logging me out. And if we go back to our terminal and we log in as the root user, and we go to var log, we can take a look at the distro migration log, which you'll see actually goes through a set of pre-migration checks. It's going to overlay the SSH keys that we've temporarily added, and then it's going to configure the network and eventually get into the zipper transaction that's needed to facilitate the upgrade. So it's going through the refresh, and then it will give you its proposal and ultimately start the file copy process. So the upgrade was successful, as evidenced by looking at the etc OS release file. You'll see that it's now SLES15 SP3. If we do a zipper LR, as mentioned previously, I now have DMS repos, and this system also has a DMS migration channel. We have a little bit of cleanup that needs to happen here. And if you go to the etc zip repos.d directory and look at the contents, I have the entries for each of the repos that were created, and I prepended all of them with the DMS, right? So if we rm DMS star here, the only thing remaining is going to be the SUSE Manager channels repo. And if I do a zipper ref now, the only thing assigned is the current DMS migration channel, right? The other thing we're going to need to rebootstrap this instance is the reactivation key, which I'm going to copy here again. And if I export this, and remove the space this time, I can very quickly rerun the final bootstrap to bring this guy back into SLES15 SP3. And you'll see that I'm now using a 15 SP3 full activation key along with the reactivation key. And the system itself has been reassigned a new base channel along with the required update channels. Again, you have an opportunity to potentially prune out what channels are required here. I mentioned earlier orphan packages being a concern. And if we go back and make sure that our salt state is complete, we have nothing pending. We type zipper ref at the prompt here, it will refresh all the software repos. If we do a query on zipper packaged orphaned, I have 3 packages here that are orphaned that potentially need to be removed. And if I look at the detail on these packages, you'll see libadns1 is a SLE12 package that was deprecated and removed. So that's relevant to not have on the system anymore. And to clean all of those up, I'm just going to use the shortcut script here that's doing the query for orphan packages and telling the system to remove them and confirming that I want to do that. And we are now good to go with no orphan packages here. And ultimately, I now have a system that has been upgraded that is ready to move back into standard operational state. The workload was along for the ride. The system is up to current assigned patch level. And ultimately, the process is now complete. A couple last things for you. As we're finishing up, I'll point you at a couple of recommended sessions. Toot 1050 is going to be delivered by Don Vosberg and Neil Bornstein, who's with the pre-sales team. Don is the product manager for SUSE Manager. They've perennially done a session on managing Linux in the public cloud with SUSE Manager over the past few years. They've added a few new topics as part of this year's overview. I highly recommend you going and taking a look. The SUSE Manager roadmap will also be presented by Don in the Futures 1148 session. And Robert Schweikert will be delivering the 1125 Public Cloud Infrastructure Deep Dive session, where if you want to understand the internals of our image creation and maintenance process, the public cloud information tool, looking at indexing images and how people are deploying, and some of the how things work under the covers, looking at how the sausage is made. Highly recommend you go into Robert's session. He is a phenomenal speaker and will ultimately be very happy to engage with any questions you guys might have. So with that, I'd like to thank you for joining the session today. I hope you found it informational. Please download the slides, download the instructions, and if you have any questions, my email is on the session, and I will be joining the networking session assigned with the session. Otherwise, contact your SUSE representative, your pre-sales engineer, or qualified partner if we can be of any assistance. Enjoy your SUSECON. Have a great day.